Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, in this video we shall study about the partial fraction. But before to discuss the four cases of partial fraction, let us know about some basic concepts which are used in the mentioned study. The first one is, what is a fraction? A fraction is a symbol which shows division of two numbers or expressions. It is denoted by n bar d. Here the upper number n is called numerator and the lower number d is called the denominator. For example, 3 by 7 is a fraction. Here 3, which is the upper number, is numerator, and 7, which is the lower number, is called a denominator. Similarly, 2x plus 3 or 3x square plus 2x plus 5 is a fraction. Here the upper polynomial 2x plus 3 is numerator and the lower polynomial 3x square plus 2x plus 5 is denominator. What is a polynomial? It is a particular type of expression. By particular type of expression we mean that in that expression the power of variable in each term will be a whole number. The whole numbers are starting from 0. In other words, 0, 1, 2, 3, 4 up to so on are whole numbers. For example, look at the first expression. There are two terms. In the first term, the power of variable x is 2. In the second term, the power of variable x is 1. So both are whole numbers and this is a polynomial. Similarly, in the second expression, we can see the power of variables in each term is a whole number. One can be written as x power 0 because x power 0 is 1 and 0 is a whole number. So this is a polynomial. Similarly, x plus 7 is a polynomial because this is equal to x plus 7 x naught. 2 is also a polynomial because it can be written as 2 into x power 0. Here the variable is x and its power is 0, which is a whole number. These two expressions are not polynomial. Why? Because look at the first expression. In the first term, the power of variable x is minus 2 and minus 2 is not a whole number. So this is not a polynomial. Similarly, in the second expression, we can see that the power of variable x is 2 by 3 and 2 by 3 is not a whole number. So this is not a polynomial. What is a rational fraction? A fractional of the polynomials is called a rational fraction. In other words, if n is a polynomial and d is a polynomial and there is no common factor in n and d, then we will say that n by d is a rational fraction, and of course d will be non-zero because if d is 0, anything divided by 0 is undefined. There are two types of fraction. One is called proper fraction. The other is called improper fraction. What we mean by degree of the polynomial? The highest power of the variable in a polynomial is called the degree of that polynomial. The degree of polynomial x square plus x plus 1 is 2 because the highest power is 2 here. The degree of the polynomial x minus 1 is 1 because the highest power of variable here is 1. Now what is proper fraction? If the degree of numerator n is less than the degree of denominator d, then that type of fraction is called proper fraction or proper rational fraction. For example, look at the first fraction. Here in the numerator, the polynomial is x minus 1, its degree is 1. And in the denominator, the degree of polynomial is 2. So, the degree of polynomial n is less than the degree of the polynomial d. So, this is a proper fraction. Similarly, look at the second expression. Here, the degree of the polynomial in the numerator is 2 and the degree of polynomial in the denominator is 3. So, this is a proper fraction. 1 over x square plus 1. Here, in the numerator we have 1. 1 can be written as x power 0. X power 0 is 1. So, its degree is 0. X power 0, degree is 0. And in the denominator we have x square plus 1. The degree is 2. So this is a proper fraction. Now what is an improper fraction or an improper rational fraction? If the degree of numerator n is greater than or equal to the degree of denominator d, then that fraction is called improper fraction. For example, look at the first fraction. Here, the degree of polynomial in the numerator is 1. And the degree of polynomial in the denominator is also 1. So they are equal. This is improper fraction. Look at the second expression. The degree of polynomial in the numerator is 2. And the degree of polynomial in the denominator is 1. So 2 is greater than 1. This is improper fraction. Look at the last expression. X power 4 divided by x cube plus 1. In the numerator, the polynomial is x4. Its degree is 4. In the denominator, the polynomial is x cube plus 1. Its degree is 3. 4 is greater than 3. So this is an improper rational fraction. There are 4 cases of partial fraction. First, we discuss the general fitting of these cases, and later on we shall use these cases to solve problems. Case number 1 is if there are linear factors in the denominator of a fraction, then how we can use partial fraction. So look at this general form. We can see in the denominator we have x minus a, which is a linear factor, x minus b is a linear, x minus c is a linear factor, and they are different from each other. So this is equal to a over first factor plus b over second factor plus c over third factor. Look at this example. Write the general partial fraction form of 2x plus 1 divided by x minus 1 into x minus 2. In the denominator, we can see there are 2 linear factors. So this is equal to a over first factor plus b over second factor. Case number 2. If there are repeated linear factors, it means that if x minus b is appearing 2 times, 3 times or 4 times, we can see x minus b is a linear factor, but whole power 3 shows that it is repeating 3 times. In such a case, we will write it as equal to a over x minus b plus b over x minus b whole square plus c over x minus b whole cube. Look at this example. Write the general partial fraction form of 4x over x minus 5 whole square. In the denominator, x minus 5 is linear and whole power 2 mean it is repeating 2 times. So this is equal to a over x minus 5 plus b over x minus 5 whole square. Case number 3. If there are quadratic factors in the denominator which cannot be factorized, then it can be written as ax plus b divided by first quadratic factor plus cx plus d divided by second quadratic factor. Write the general partial fraction form of 1 over x square plus 1 into x square plus x plus 1. Look at the denominator. We have 2 quadratic factors. So this is equal to ax plus b divided by first quadratic factor plus cx plus d divided by second quadratic factor. Case number 4. If we have repeated quadratic factors, for example, we can see x square plus bx plus c as quadratic factor and whole square mean it is repeating 2 times. Then we can write this as ax plus b divided by x square plus bx plus c plus cx plus d divided by x square plus bx plus c whole square. Look at this example. Write the general partial fraction form of 1 over x square plus 1 whole cube. X square plus 1 is quadratic factor. Whole cube mean it is repeating 3 times. So this is equal to ax plus b divided by x square plus 1 plus cx plus d divided by x square plus 1 whole square plus ex plus f divided by x square plus 1 whole cube. Partial fraction is a method with the help of which we convert a single fraction into the sum of 2 or more than 2 small fractions. For example, this is a single fraction. When we apply the partial fraction on this single fraction, as a result we get that this is equal to the sum of these 2 fractions. Now how we get these 2 fractions? Let us solve this question. In example number 1, to find the partial fraction of 3x over x minus 1 into x plus 2, we can see in the denominator both terms are linear. X minus 1 is linear as well as x plus 2 is linear. So we shall use case number 1 here. According to case number 1, we write a over first factor, which is x minus 1, plus b over second factor, which is x plus 2. Now the task is to find the value of a and b, and once we get these 2 values, we shall substitute the value of a and b in equation number 1, and that will be the required solution. To find the value of a and b, we multiply each term with the LCM of the 2 terms on the right hand side. In other words, we multiply each term with x minus 1 into x plus 2 and we get this equation. We can see from the left hand side, the similar terms will cancel and we will get only 3x. Then from the first term on the right hand side, x minus 1 will cancel with x minus 1. And we get a into x plus 2. Then from the second term, x plus 2 will cancel with x plus 2 and we get b into x minus 1. Next we substitute x minus 1 equal to 0 to get the value of x from this, which is equal to 1. So putting this value of x in this equation, from the left hand side we get 3 into 1 which is equal to a into 1 plus 2, because instead of x we have now 1 here. Then plus b 1 minus 1. We can see from the left hand side we get 3, which is equal to 1 plus 2 is 3. So we get 3a, and 1 minus 1 is 0, so that term will become 0. And when we simplify 3 is equal to 3a, we get the value of a, which is 1. To get the value of b, we put x plus 2 equal to 0, from which we get the value of x, which is minus 2, in the above equation. Now, when we substitute x is equal to minus 2, in the left hand side we get 3 into minus 2, which is equal to a into, instead of x now we have minus 2, and then in the second term instead of x we have minus 2. From the left hand side we get minus 6, which is equal to minus 2 plus 2 is 0. So the first term becomes 0, and from the second term we get minus 2 minus 1, which is minus 3. So we get minus 6 is equal to minus 3b, and when we simplify this, we get the value of b, which is equal to 2. Now we have the values of both constants a and b. We will plug in these values in 1, and that will be the required solution. So instead of a, now we put 1 here, and we get 1 over x minus 1. Instead of b, we put 2 here, so we get 2 over x plus 2, and that is the required solution. In example number 2, there are two factors. One is quadratic and the other is linear. But we can see the quadratic factor can be factorized by using the formula a square minus b square, which is equal to a minus b into a plus b. And you can see the last two terms are similar, so we can write it as 1 over x minus 1 into x plus 1 whole square. To factorize this, the first term is linear and it is different from the other one. So we use case number 1 on the first factor, and we write a over x minus 1. The second term is linear, but it is repeating 2 times. So we use case number 2 for the second factor, and we write b over x plus 1 plus c over x plus 1 whole square. The next task is to find the values of these constants a, b, and c. So we multiply both sides by the LCM of the right hand side, and we can see in the left hand side, when we multiply with x minus 1 into x plus 1 whole square, similar terms will cancel and we will get only 1 here. From the first term, x minus 1 will cancel with x minus 1, and we shall get a into x plus 1 whole square. In the second term, 1x plus 1 will cancel, and we get b into x plus 1 into x minus 1. In the third term, when we multiply with the LCM, x plus 1 whole square will cancel with x plus 1 whole square, and we get c into x minus 1. Next we put x minus 1 equal to 0, from which we get the value of x equal to 1. In this equation now, for each x, just put 1 here and we get this equation. The last term is 1 minus 1, it will become 0. In the second term there is 1 minus 1, it will become 0. In the first term 1 plus 1 is 2, 2 square is 4, so we get 1 is equal to 4a, and when we divide by 4 both sides, we get the value of a, which is 1 over 4. Next we put x plus 1 equal to 0. and from this we get the value of x, which is -1. Now in this equation, in each place of x we put -1 and we get this equation. Now the first term becomes 0 because there is -1 plus 1. The second term becomes 0 because there is -1 plus 1, which is 0. And the third term, -1 minus 1 is -2, so we get 1 is equal to -2c, and when we divide both sides by -2, we get the value of c, which is equal to -1/2. Now only one value of b is remaining, but there is no other linear factor which we should put equal to 0. Doing this procedure we will get the value of b. So what we should do now? Now we shall compare the coefficients of x square, x and constant on both sides. For that purpose we simplify it. X plus 1 whole square is equal to x square plus 2x plus 1 by using formula a plus b whole square, which is equal to a square plus 2ab plus b square. In the second term, x plus 1 into x minus 1 becomes x square minus 1 by using formula a plus b into a minus b is equal to a square minus b square. And the third term is as it is. Multiply a with each term, then b with each term, then c with each term. And then take x square common from these two terms, so we get a plus b into x square. Take x common from these two terms, so we get c plus 2a into x. And write constant terms, a minus b minus c. Comparing the coefficients of x square on both sides, we can see the coefficient of x square on the right hand side is a plus b, and on the left hand side it is 0. The coefficient of x on the right hand side is c plus 2a. On the left hand side it is 0. These are constants on the right hand side, and on the left hand side the constant is 1. From equation number 1, we can write b is equal to minus a because we already have the value of a, which is 1/4. So we get the value of b, which is equal to minus 1/4. Now we have all values of a, b and c. So instead of a, now we put 1/4. And for b, we put its value, which is minus 1/4. For c, we put its value, which is minus 1/2. And that is the required solution. In example number 3, we need to factorize the denominator. Here we use formula a cube plus b cube, which is equal to a plus b into a square minus ab plus b square. According to that formula, x cube plus 1 is equal to x plus 1 into x square minus x plus 1. We can see the first factor is linear, and therefore we use case number 1 for the first term, and we write a over first factor. The second factor is quadratic and we cannot factorize it. So here we use case number 3. According to that case, we write bx plus c divided by second factor. And now we need to obtain the value of a, b and c. So we multiply each term with the LCM of the right hand side, and we can see from the left hand side the denominator x plus 1, x cube minus x plus 1 will cancel, and we get only x square plus 1. From the first term on the right hand side, we can see x plus 1 will cancel with x plus 1 and we get a into x square minus x plus 1. From the second term, x square minus x plus 1 will cancel and we get bx plus c into x plus 1. Next we put x plus 1 equal to 0. From this we get the value of x is equal to minus 1. So we substitute this value in each place where we can see x. Just like in the left hand side, x square become minus 1 square plus 1 equal to, now in each x we can see in that place there is minus 1. From the last term, minus 1 plus 1 is 0. So the last term becomes 0. And the first term, minus 1 square is plus 1. Minus into minus 1 is plus 1. And there is another plus 1. So we get 3a. And from the left hand side, minus 1 square is plus 1. 1 plus 1 is 2. So we get 2 is equal to 3a. And when we divide both sides by 3, here we get the value of a, which is 2 by 3. Now we don't see any linear other factor, so that we can use this procedure and obtain the value of b and c. So we shall compare the coefficients on both sides. For that purpose, we multiply a with x square, then with minus x, then with plus 1. Similarly, we multiply bx with x, then bx with 1, then we multiply c with x and c with 1. Now taking common terms, we can see x square is common in these two terms, so we write a plus b into x square. Then x is common in 3 terms, so we take x as common and then write the constants. Now compare the coefficients of x square, x and constant on both sides. We can see the coefficient of x square on the right hand side is a plus b, but on the left hand side that is 1. The coefficient of x is minus a plus b plus c on the right hand side. On the left hand side that is 0. Constants on the right hand sides are a plus b, and on the left hand side that there is 1. Let us now solve these 3 equations to find the value of b and c, and we can see from the first equation a plus b is equal to 1, but we already have the value of a, so we write b is equal to 1 minus a and then substitute the value of a here. Now simplify this and we can get the value of b, which is 1 over 3. Similarly, from the last equation, a plus c equal to 0. Again, we already have the value of a, so we write c is equal to 1 minus a and then we put the value of a here. When we simplify, we get the value of c. So now we have all values of a, b and c. We need to just substitute these values in equation number 3. For a, we put its value 2 by 3. For b, its value is 1 over 3. For c, its value is 1 over 3. And when we simplify, we get the required solution. In example number 4, there is a quadratic factor x square plus 4 in the denominator and we cannot factorize it. It is repeating 2 times. That is why we shall use case number 4 here. According to case number 4, we write ax plus b divided by x square plus 4. Then we write cx plus d divided by x square plus 4 whole square. Next we multiply each term with the LCM, which is x square plus 4 whole square. First we multiply left hand side, then the first term and then the last term. From the left hand side, x square plus 4 whole square will cancel and we can get only x cube. From the right hand side, in the first term, 1x square plus 4 will cancel with 1x square plus 4 and we get ax plus b into x plus 4. From the second term, x square plus 4 whole square will cancel and we get cx plus d. Next we multiply ax with x square and then with 4. Then multiply b with x square and then with 4. And finally write cx plus d. Now rearrange and combine the terms in which we can see x is appearing. So we take x as common. We have 4a plus c whole into x and then write the constant terms. Finally, we compare the coefficient of x cube, x square, x and constant on both sides. We can see the coefficient of x cube on the right hand side is a, on the left hand side it is 1. So we write a is equal to 1 and we get the value of a. The coefficient of x square on the right hand side is b and on the left hand side it is 0, so we get the value of b here, which is 0. The coefficient of x is 4a plus c on the right hand side and on the left hand side it is 0. Here we can see that we already have the value of a, so we write it as c is equal to minus 4a. Now substitute the value of a, which is 1. 4 into 1 is 1, so we get the value of c, which is minus 4. Now compare the constant terms. On the right hand side, the constant terms are 4b plus d. On the left hand side, it is 0. Again, we can see the value of b we already have, which is 0. So we write it as d is equal to minus 4b. When we put the value of b here, 0 multiply with anything is 0. We get d is equal to 0. We have now all values of a, b, c and d. Let us substitute these values in equation number 4. For a, the value of a is 1, so we put 1 plus b, b is 0, so we put 0. In the second term, the value of c, it is minus 4 and the value of d is 0. When we simplify, we get the required solution.